Hello and welcome to the Section 7.1 lecture. Today we're going to be looking at the start of the second half of our winter term material here in Flipped Algebra 1. We kind of make a big transition here from really talking about graphing equations and writing equations of graphs or of situations, and now we're going to be looking at inequalities, so kind of a big turn of events here, because in the past we've looked at things that are equal, and now we're looking at things that technically aren't equal. And that's the main idea behind inequalities. That's what the word inequalities means. It means that it's not equal. Now, we are going to find some cases where that's only partly true, but let's go ahead and jump right into it. So in this table here, I have my 4 standard inequality symbols. I have some meanings here, so what it means word-wise. So the first one here, we have less than. And then we have greater than. And I know there's always confusion that comes when you're trying to figure out, well, which symbol do I have? How do I say that in words? And kind of my go-to, I guess solution for that, or kind of troubleshooting for that, is to write something that you know is true. So maybe I know that, well, 4 is smaller than 6, so I can write that and put the symbol that goes there. And really, where the words for these symbols come from, it really comes from having to read it as a sentence. A sentence like 4 is less than 6 is true, and that kind of helps us understand why that symbol is called less than. And I know I've had classes that, give me the symbol this way, or put the line under it if you have to. And that works, but we want to be able to communicate math verbally just as much as we do visually. Okay. The other two that I have, the line underneath means that equal to is an option. So this is less than or equal to. And the last one is greater than or equal to. Now, when it comes to these bottom two, and I know specifically at this point in time, there are some equation editors that are good at this, and there are some that are not. I know for a fact that Microsoft Word's equation editor will do this. I'm not 100% sure on how Google Docs is working at this point, but I'm sure they'll catch up eventually if they're not already. Some things that can make typing these things a little bit easier. Obviously, these two are pretty straightforward. They're on your keyboard, right? So this one is like Shift plus the comma. That looks like a J, but it's a comma. This one is Shift plus the period. Now, in typing these two, if, at least in Microsoft Word, if I go less than or Shift comma, and then I type an equal sign, a lot of times it'll automatically default to give you this. Similarly, if I go Shift period to get a greater than symbol, and then type an equal sign, and a lot of times you have to hit space for it to understand that's what you want it to do. They will automatically change them to these symbols. So that's a little bit quicker way. I know, like in both equation editors, there's like a list of operators that you can pull from, but that just takes longer. Okay. So it is handy to be able to just go and grab it if you need it. And, or I should say, it's a lot easier just to type it if you know how to do that. takes you from having to take yourself off of your keyboard and onto your mouse, and it is a little bit quicker. So I want to talk about some other phrases that can mean these same operators, these same relations. So a couple that we have for less than, you could say something like is smaller than. You could say fewer than. You could even say something like below. Okay, and it all kind of comes into dealing with the context that you're working with. All right, sometimes and maybe I would even say that this is below, just to make like this example here work, in that 4 is below 6. And then as far as an example goes, as in a one variable inequality example, we might have something like x is less than -5. Okay. Let's see the next one here, greater than. We could say things like, well, we could kind of say the opposite of what we have, is larger than. Maybe I would say is more than. Or is above. And again, giving you multiple options to be able to put it in a context that makes sense. Always, if you're taking symbols and turning them into words, make sure that you've tweaked it to where it makes a little bit more sense for your situation. And so again, we might have something like y is greater than 10. That could be a good example there. Less than or equal to. There's a little more kind of word choice when it comes to the or equal to's that's more commonly used. Some other things, sorry, for less than or equal to could be something like is at most. And that's a very common kind of tough one to work with, because most usually means like something greater, but when you're saying is at most, that actually means less than or equal to. It means it can be that number that you're talking about or anything smaller. Another way kind of to say this, but it does work for less than or equal to, would be no more than. An example for that, maybe we have G is at most 8. And then last one here for greater than or equal to, similar to the ones we have, we could say is at least. Or even no smaller than, or no less than. And we might have here that H is no less than 12. So these are the 4 common inequalities that we deal with. There is one that's a little bit, I'll say less informative, but there is the most basic inequality, and that's the equal sign with a slash through it. Okay, and really what that means is just not equal to, or the same idea with inequality. Again, it's less informative because it doesn't really give us any information other than it can't be a certain number. Okay, and that one more traditionally gets changed to it's either less than or greater than, but it can't be one of the equal tos. Okay. So then we get to a point where we want to talk about how to display the solution of an inequality. And sure, it's great to know that let's use our top one, that x is less than -5. Like that's some good information. But what does that look like? Okay, what does that look like? So we're going to go over two different possibilities here. So let me get a little setup going. And the way that we do it is that we use a number line most often. So for x is less than -5, I need two pieces of information at sort of a bare minimum. Okay, number one, I need to know where 0 is. Let's put 0 right there. Then the other thing I need to know is I need to know my kind of target number, my important number for the problem. And for that I have -5. And so I need to see these two things. Now if you want to add in the -1, the -2, the -3, and the -4, and maybe some on both sides, that would be great. And that would be very helpful. But it's not required most of the time. Now I have to ask myself, what numbers are smaller than or less than -5? Where do smaller numbers live? Okay, smaller numbers live to the left. So I could say something like, now an answer to this might be, well, -6 is less than -5. But hey, -5.5 is also less than -5. So there's a lot of answers here, right? There's a lot of things that are less than -5, and this is why we use a number line. And it really comes down to everything farther left than -5 is less than -5, but not -5 itself. I do have to avoid that. And the way we avoid numbers on graphs is that we put a circle there. Okay, putting a circle there means avoid that number, but for now everything else is good. So then we'll circle that number. Then we want to shade which way all those other numbers live. Well, where is -6? Oh, it's right here. This is -6. -5.5 is right here, but hey, even -5.000001 would be less than -5. So I want to shade all this stuff on the number line. And then it keeps going. So I'm going to draw an arrow here and actually fill that in as well. Sorry, but the filling in doesn't work too good with this pen, but that's okay. Okay, just trying to make it clear. I've taught it this way. I really like this way because it really makes me feel what numbers are there. I've also done this one as well. And so you can kind of pick which one you want to do. I personally do like the shading, even though I've done the line up above as well. Okay, so just use your best judgment there. Another thing that we have to deal with, let's look at one of our greater thans or equal tos. Let's look at our h is greater than or equal to 12. So again, I need to know where 0 is, and I need to know where 12 is. Those are the two numbers that I need to see. And so what numbers satisfy this? Well, 13 is bigger than 12, or equal to 12. It's one of those. 14 also. What about 13? Or sorry, what about 12? Is 12 greater than or equal to 12? Well, yes, it is. It's equal to 12, so it satisfies our condition here. So in the sense of graphing this, we're going to draw this circle, but we don't want to avoid 12. We want to include 12, so we'll fill that in. And then we want all numbers that are bigger than 12. So those happen on this side. Shade that, fill in that line. Now, notice that it didn't show up very well, but when I was shading, I was shading it vertically. And that's what I want to see you do, shading this vertically, because if all you do is try to draw over that line, that's really hard to tell. Especially, if I were using a pencil, right? It'd be hard to tell if I was just trying to do this and shade over this line. This isn't where the right answer is, but I don't want to see this. I want to see some vertical shading that really shows me that solution. Okay. And now our other main goal today is going to be translating the verbal side of things into the mathematical side. Okay. The first one here says that Gal has less than $10 in his wallet. Okay. So maybe I'm saying something about his wallet, and it has less than $10. Okay. Now, just as easily, we can graph these. And I want you to graph them as well. Again, I want to know where 0 is, and I want to know where 10 is. Now, there are some sort of outlier things here, some things that wouldn't work, but for purposes of today, just go ahead and shade everything smaller than 10. I would say that on average, I probably can't have a negative amount of money in my wallet, but who knows? Maybe I've got a debit card that's overdrawn. Okay. The NBHS JV team will win at least 8 games this year. So let's say games is at least. Now, where does at least fall? At least falls in this greater than or equal to. So meaning that they can win 8 games, but they could also win more. Okay, don't hold me to this, but we'll do our best. So again, I want to know where 0 is. I want to know where 8 is. And then we can go ahead and graph that. They can win 8 games. So we're going to fill that in. If they win 8 games, in other words, our requirement is satisfied. It is a requirement. So dating me a little bit, we have a problem about Peak, old alternative school. Peak will have no less than 35 students. So what does no less than mean? Okay, and maybe we'll say that your students will be no less than 35. Okay, so that means that they might have 35, but they're not going to have anything less than 35, so maybe 35 or more. So we call that greater than or equal to. Need to know where 0 is, need to know where 35 is. We've got those 2 things. We are good to go. 35 is a solution, so we fill in the circle. And then we shade where there's more than 35, and that's always to the right. More things happen to the right. Last one, NBHS will have no more than 40 teachers. So maybe the number of teachers can be 40, but it can't be more than 40, so it has to be less than or equal to 40. Okay. have those two. We can graph them. Say we've got 0 here, 40 here. Again, 40 is a solution. 40 would work. So we're going to fill in that circle at 40 and shade everything to the left. Try to keep your work as neat as you can, but still as obvious as you can. Don't make me guess which side of the line you were shading. That's when you get things wrong. Okay, so summarize your notes. Let's look at practice and application problems. I want you to pick 6 of the top 2, and we'll do all 4 of the bottom. So for practice, we'll say pick 6 and 1 through 8, and then 9 through 12. Application wise, let's say all of them. The first 2 will go pretty quick. The second one, or the third one, I should say, is just a 4-parter. Okay, but it doesn't make sense to only do part of that third one. Okay, hopefully that helps. I want you to have a great day. Practice enough for that mastery challenge, and we will see you in class.